Here we are at the last meeting. Okay. Last meeting is right here. Well, no, it's not the last meeting. It's our last non-exam meeting. We're gonna be going to deliver a practice final. It's gonna be a pretty short day today, probably like 45 minutes, maybe an hour. So we'll see. The final exam is scheduled for next week, and it's going to be on a different time. I talked about this earlier, but it's right here. It's on December 9, and it's at 6 p.m. to 8:50. It says 8:50, but you're pretty much gonna have until 9 p.m. Okay. So yeah, let's get started. I published a practice final earlier. It's kind of incomplete though, but it should get the point across. Here is the practice final in the quizzes section. It contains 6 questions. I believe the actual final is gonna have like 7 questions. But the point of this practice is kind of to get a sense on the format of things. The format is going to be pretty much the same as the midterm. So I would recommend going back to your practice midterm and the midterm and practicing them as well. Those will be supplementary practice to this. I did mention that this practice final is incomplete. I didn't get a chance to implement a remote checker program yet. You might have remembered in the practice midterm and the midterm there was a remote checker. Yeah, I didn't implement that in this one. So yeah, you'll basically have to sanity check your own functions, and I'll talk about how to do that in a bit. All right, let's see. Okay, let me go ahead and download this over here. So here's a notebook. Okay, there it is. I downloaded the notebook. There's 2 pieces to here. One is on the Canvas quiz itself, and then the other is on the notebook. The notebook is pretty much like a playground where you can test your solutions. So I'm gonna go into my exams directory over here, and then let me drag this over. Practice final. Here we are. Practice final 2025. Okay. Cool. Here's some instructions. It's the same thing as on Canvas. So yeah, same instructions. I will try to give as much partial credit as possible. Pretty much, if your code has minimum a function with a docstring and takes the correct amount of argument, then you should be getting at least a bit of partial credit. And if the body of the function makes some sense, then yeah, I'll agree with that in mind. If you're unsure about certain functions, or maybe some questions are ambiguous, feel free to state a comment and attempt the questions with those in mind. For example, if you're not sure what a question is asking, maybe put a comment in your code. Be like, I'm assuming that we want to do this, and then I'll grade it with those assumptions in mind. Okay, cool. So yeah, as usual, the code of conduct. This is an open book quiz, open note quiz. It's you can refer back to your previous lessons, your labs, the internet as well. Just the only really restriction is not asking large language models to do everything for you. So that's pretty much it. All right. Let's see. We don't really have to run this first cell, by the way. This first cell is supposed to load in a remote checking program, but I didn't even implement one yet. So yeah, you don't have to run this first cell. This notebook contains a playground. It's really just a bunch of empty cells. We're gonna put in the solution, question 1, question 2. Each of these questions have some more blanks here like this blank is testing your function locally. This means to invoke your function and sanity check the results yourself. So I'll go over this stuff in a bit. Okay, here let me load up the canvas over here. So there are two pieces. Let me put them side by side. Okay, put it side by side. Okay, hopefully people can read this. Let me zoom out on the canvas a bit. Okay, cool. I'm gonna click on take the quiz. The second you click on take the quiz, there's going to be a 3-hour timer. Okay, take the quiz. Here we go. All right. Cool. Yeah. So the point of this practice is to kind of practice the format. It's not going to cover some content that you'll see on the exam. So I would recommend going through all of your previous labs and all your previous homeworks, the projects. If you can fully understand all of those, then you should be pretty confident on this final over here. So yeah, let's go ahead and practice what the stuff are. Okay, question 1 right here. This is asking us to write an algorithm, a filtering algorithm. You might have remembered from a while ago over in the algorithms, the lesson 17. There's a section that's called filtering. Filtering means we're taking in a data structure and we're going through it and returning a possibly smaller data structure. That's what this first question is asking for. It says write a function called listFilter that takes 2 arguments. First argument is a list of numbers, and then the second is a number. The descriptions of the description, the purpose is to filter the list and return only the numbers that are less than or equal to the limit. So you could take a look at these parameters here. This is a description of what the inputs to the function are. We'll take a list of numbers and then a single number, which represents the filtering method, the threshold. Okay, there are a couple examples that I put here so people can maybe visualize the goal a little better. This is like a testing cell. You can imagine like a sanity checking cell. I'm gonna work backwards from here so people will kind of see what the intended goals are. So if I copy in this first test over here, this is attempting to invoke a function that doesn't exist. Here we go. I just went ahead and pasted this first piece. And yeah, hopefully people can kind of see what the goal is. The goal is we should have a function named listFilter, and we can give it any arbitrary list. If the list happens to be these numbers here, let me zoom in a bit. If the first argument happened to be this arbitrary list, and then the second happens to be this limit, the function should return a possibly smaller list. And in this case, it is smaller because there's only 3 numbers that are less than or equal to the limit. 0, 5, and 1. 5 is the limit here. All right, people will see what I mean by kind of working backwards a bit. Okay, cool. Once again, I am working backwards. So if I play this, I'm going to get an error. The list filter is not defined. So let's go ahead and define this function. On the actual final, you'll probably you'll be adding in another tag, by the way. There's going to be another tag where you type in like at something something. I haven't made these up yet, but there's going to be a tag that represents what your problem is. Because everyone gets a randomly generated exam. Everyone's gonna have a different types of questions. So yeah, but it's just like the midterm. On the midterm, you had to add in another tag, but not on this practice one. Okay, whoops. Let me clear this. Clear. Okay, let's go ahead and define this function. So define this function called listFilter. For any minimum partial credit, the function should have the correct number of arguments. In this case, it has 2 arguments, where the first one should be called number list, and then the second one, the limit. Also, at the bare minimum, you should have a doc string that describes what your function does. This is for a good reason. It's one is so you can pretty much understand what the question is asking for. So I'm gonna go ahead and set up a longer doc string here. This is a it's a filtering algorithm that that filters. Let me see, how can I say this? I'll just say filters a list based on a threshold. Filters a list based on threshold. There's 2 parameters, 2 arguments. One is the number list. This is the list of numbers. And then next one is a single number limit. This is just the threshold. Okay, and this function is expected to return a list. Returns a possibly smaller list. Possibly smaller because there's a chance that the list can have numbers that are all bigger than the limit. Cool. So yeah, I am working backwards. You might want to test frequently. I would probably press play by now, so we can check for syntax errors. Let me press play. Okay, cool. There's no syntax errors in this function. Let me go ahead and invoke it real quick, just to see what happens. So I'll go ahead and invoke the function. Okay, there it is. I invoked it, and the result ended up being none, which makes sense because this function doesn't return anything. Okay, so let's go ahead and set this function up to return a list. I would recommend kind of recalling, like thinking about when we kind of did this stuff, especially during the exam. You might be like, how do I do this? Well, we kind of did this in the algorithms, so I would suggest looking at the appropriate lesson that covers this. The lab also covers this stuff too. So yeah, this is pretty much what we're doing here. I'm on lesson 17 right now, by the way. This is pretty much what we're doing. So there's so many ways you can do this, by the way. Well, I think an easier way to understand this is to first initialize an empty list and then start filling it in later. So I'll go ahead and initialize. I'll call it like output or whatever. I'll call it output, which is going to represent a list. This is initialized to a empty list, but we're going to fill it in later. If anything, I'm gonna go ahead and return this at the bottom. Just so I don't forget about it later, because in the middle we are planning on populating this list. Okay, so let me press play here. Let me sanity check this to make sure it prints an empty list. Okay, cool. It is printing empty list. Cool. You want to test frequently. It's especially if you're going on to the computer science things. Your programs will end up being larger, so you don't really want to type in a very large program and then test it. You kind of want to do some unit testing. So I'm kind of going on a tangent right now, but in software engineering there's something called unit testing. Unit testing is a way of isolating pieces of your code and testing it to see if it has expected behavior. This is good because if you don't verify the smaller things and you put it together later, it's possible that you'll have errors that you never really expected. So yeah, I'm pretty much encouraging unit testing. Okay, here let's get to the point. So this function should go through the number list. Hopefully people are thinking of some sort of loop. So you could use a while loop, you could use a for loop. I'm probably going to stick with a for loop because it's going to be cleaner and easier to read, I think. So I'll stick with a for loop that goes through the number list. Okay, for number in number list. You can name this variable anything. I'm just naming it number. And then we need to check if that number is less than or equal to the limit. That's what the question here is asking for. So the condition is if it's less than a limit. So I'll put the condition here. If the number is less than the limit. Oh, I think it's less than or equal to actually. Less than or equal to, because that's what it says here. So if we meet the threshold, then we can go ahead and populate that list. One way you can do it is with the append method. The lists do have an append function where the argument is the element to insert to the end of it. And in this case, it's just a number because yeah, that's the number being that meets the threshold. Okay, let's test this. So I'll press play, boom, and then let me invoke this function over here. Okay, cool. Yeah, this looks good. Our arbitrary list is right here, and there's only some certain amount of numbers here. I would test more, by the way, like maybe changing the limit and sanity checking yourself. Like if I were to change the limit here to like 15. If I were to change the limit here to 15, this is telling the function to filter based off 15, meaning that we should get all of the numbers except 20. So let's press play here. Boom. And yeah, there you go. It looks good. So yeah, we're testing our function locally and sanity checking the results. Okay, cool. There are some other example test cases here that you can test. So let me copy this over. This last one here should print an empty list because the list never, each of the elements is never under 5. So let me test it. Okay, cool. It did print an empty list. Great. All right, people cool with this so far? Okay. Okay, cool.
Hey, Zach.
Yeah, what's up, Jim?
Instead of creating another list, can you modify the existing list by removing elements that are outside of the range?
Oh yeah, I believe you can do that as well. The reason is because lists are mutable, meaning
Yes.
yeah, exactly. Yeah, lists are
So you
mutable.
could
Mhm.
so you could modify that list rather than create another list, and would that be more efficient, better memory usage,
It would be
faster?
yeah, it would be way more space efficient. It'd be way more.
Would
The
it be clearer?
Would it be clearer? I think it would be clear. Yeah, I think it would be clear because you're probably gonna end up doing something like here, let me try that. Let's see. I'm very tempted to do like a one-liner here. Very tempted, but
Oh, go for it.
yeah. There's a
Let's
really
see.
cool one-liner.
It's time to show off your chops.
Let's see. I don't really want to bring this up too much, but I was gonna pull up some lambda functions in Python. So if you're curious about lambda functions in Python, these are like great ways on doing single one-liners. Lambda functions also exist in other languages as well, but we haven't really covered this stuff. It's some cool stuff though. But basically, a lambda function looks like it's like a shortcut on defining a function. So one way you could do this is kind of what Jim said right here. Like let me say output is equal to uh, hmm. Let's see. You could do like hmm. No, no, never mind. I was actually going to use a function that does everything for us, which you totally could do. I was gonna end up using this function here called, I think, filter. Actually, is there a filter function? Yeah, there is. There's already I was gonna use something like this, and the first argument to this filter is a lambda function, or it doesn't have to be a lambda function. But if I were to use this, it's kind of defeating the purpose of kind of learning algorithms. So here,
Yeah,
let me try real quick. Let me just try
I
this.
didn't mean to send us down a rabbit hole.
It's all good. I actually, this is some cool stuff. You guys are both moving on into computer science, the department. So it's likely that you'll have to kind of get good at these lambda functions. So I'm basically gonna filter the number list, but the number list, we need to define some sort of function to filter off of, and I think this function here needs to return a boolean. So I'm going to create a lambda function where the number must be less than or equal to the limit. Okay, let me test this real quick. Okay, return output. Test this here. And then test this here. Okay, we're almost good. If anything, these are filter objects, and these are called generators. Generators in Python is kind of like a source. It's like a source of traffic. If anything, I need to convert this back into. I need to convert this generator into a flat list. So one way you could do that is by just wrapping it in this list conversion over here. And let me document what's happening here. So that it's a flattening the generator. So the generator here is output. Okay, let me test this over here. Test this over here, and yeah, there we go. We get the same thing. So yeah, I'm pretty much saying most of your exam questions can probably be done in one line. You know, you could do this in one line. You just gotta, you could go ahead and return this over here. Return this list, and then put another parentheses here. Yeah, I guarantee most of your problems can be done in one line here. Cool. Yes, this thing is the same thing. So yeah, good old lambda function. This is some really great stuff. It's some cool stuff. There's a thing called lambda calculus. Once again, I am going on a tangent, but I feel like folks might find this stuff interesting. There's a literal courses dedicated to lambda calculus, and it's kind of like a theoretical way of representing the functions that you just saw. So yeah, it's pretty cool stuff. Yeah. Thanks for that, Jim. Hey, always feel free to let me know. Always feel free. So this is just a cool shortcut way cool shortcut way. The more readable and understandable way that people might be familiar with is the loop. So let me get that loop back up here. And then output. Output got append. Number. Oh no, I need to put this in a condition. My bad, forgot about that. Indent this. Okay, cool. I just restored it back to I would consider this the naive method, because there's more efficient ways on doing this. Okay, let's see. Okay, there's so many. There's an infinite amount of ways you can solve this problem. So many. Okay, let me bring this back up. Okay, cool. All right. Let's see. There is a temporary placeholder here that I commented out. On the actual exam, there's going to be a remote checker, which probably takes like 10 seconds to run. It's because it does a lot of things in the background. It's starting up a server. It's gonna have to double check some things, but I would probably rely on testing your function locally. It's a good practice to do that. Okay, let's move on to the next ones. Okay, question 2 right here. This is asking us if we can go through a file. So you might remember a while ago over here, in lesson 13, there was a thing on files. The point of files was to read from storage. For example, you'll have like maybe text files in the storage, and maybe you wanted to open those in Python to analyze for some reason. So yeah, if you're okay with this stuff, then this stuff should be fine. We actually did the same exact question in a lab. There was a lab over here. I think it was lab. Let me see, the lab on files. Okay, the lab on files over here. There was a question summing values. So I'm on lab 13. There was a question on summing values. So if you did this, this exam question is pretty much the same. And this is going to apply to the actual final exam too. A lot of the questions you can pretty much find if you dig in your notebooks a bit. So yeah, this is pretty much what we're going to do. This question is saying, hey, it should take an argument. The argument represents the name of a file. For the purposes of this question, we can assume that the file will contain 4 numbers. So yeah, 4 numbers, you can assume that. And the function should return some sort of Boolean. The Boolean represents whether or not those numbers exceed a certain number. So in this case, if it exceeds 100, then we should return true. Okay. Cool. So let me set up a local testing thing real quick. Kind of work backwards a bit. I'll go ahead and create a file, because a file is stored in the storage. So I'll go ahead and create a file, and I'm gonna make it adjacent to this practice final notebook so I can access it easier. So I'm gonna create it into this exams folder. Okay, you can call it whatever you want. I'll call it like numbers.txt. Okay, and I'm gonna go ahead and copy these numbers over here. So copy, paste. Here we are. We have a plain text file. Oh, make sure you save this, by the way. Control S. There's a plain text that contains 4 numbers. The yeah, the practice final here. The goal is to go through any arbitrary file, by the way. So it's not going to be just this file. You can assume these are arbitrary numbers. Okay, so yeah, there's a file there, and we need to set it up. So here, let me go ahead and set this up backwards. So if I were to call the function file sums and put in the file name, in this case I called the file name numbers.txt. So if I were to say numbers.txt, this function should go through those four numbers, add them up, tell us if it's bigger than 100. In this case, it is greater than 100. Yeah, the sum is greater than 100. So this should return true. So if we print it, it should print true. Should print true. Okay, here, let me set up another test case. Actually, I'll set up another one. Like, let me make another numbers text file. I'll call this. Whoops, this is not a text file. This is a notebook file. So let me delete this. Delete. Okay, make a new file. I'll call this small numbers. Small numbers.txt. And then just gonna put like 4 small numbers here, like 5, 7, 3, 9. Just some small numbers. The sum doesn't reach 100. So if we were to use that, let's see, where's my okay, running out of space over here. If I were to put in that file small numbers, this should return false. So it should print false. Okay, so yeah, just setting up the local testing. You should probably do this too on your actual final, because if you do this on your actual final, it'll signify that you understand the inputs and outputs. Like you understand the overall goal of the question. So there's going to be more partial credit if I see a lot of local testing. Okay, cool. Let's go ahead and set this up. So there should be a function here. I'll call it file sums. Okay, file sums. There we go. And then it's going to take one argument, the name of the file. Okay, file name. Cool. And then a doc string. This is the bare minimum you need for any minimal credit. Okay, let's see. So let me put the purpose here. The purpose is to it determines whether or not the first 4 numbers determines whether or not the first 4 numbers in the file exceeds 100. Whether or not the sum. So it determines whether or not the sum of the first 4 numbers in a file exceeds 100. Cool, there's only one argument here. It's the file name, which is a string. It's a string that represents the path. Represents the path to the numbers. Okay, this function is expected to return a Boolean. Returns Boolean. Okay, cool. Let me press play real quick. It's really easy to make like indent errors. I think a very common error that people will do is maybe messing up their indents like this right here. I feel like this would error out. Oh, that didn't even error out. I've seen some error before that people have made. Is it this right here? Yeah, yeah. This is a very common error when people are kind of rushing. So yeah, make sure you get your indents. Okay. Python cares about indents. In other languages, they don't really care too much. Okay. As a temporary placeholder, I'm gonna go ahead and return a dummy value. It's gonna return false for now, just to make sure that the function is being called. So yeah, temporary placeholder. Press play. Okay, cool. It's printing false for both of them. Cool. Now we can go ahead and set up the function. First things first, we need to open up the file. This is an arbitrary file. So if you're on the recording, you know, I would try this out yourself. By the way, probably take a look at your previous labs. So first things first, we need to open. There's a function called open. I'm going to open up the file name here, and I'm also going to open up in read-only mode. You actually don't need this second argument here because it's read-only by default, but I'll do it for safety reasons and readability. This function does return like a pointer, which I'll call like a file handle. This file handle represents is like a remote control that can access the file. Okay, and in a good programming practice, you always close it. Otherwise, you're gonna have memory leaks. Memory leaks can be expensive. Okay, there we go. I closed it. In the middle, we're planning on summing up the numbers. So we did do this in the lab. I'm gonna give you a quick peek real quick. So lab 13, boom. This is pretty much what we're doing here. We're gonna, one way you can do it is like this. There's so many cleaner ways you can do this, by the way. I'd probably take some time to explore. There's a lot of different ways. So I'm just gonna do it manually. This way more people can understand here. So go ahead and grab these four. As you recall, these read lines right here, it's seeking through the file. It's seeking line by line. That's what it's doing, and they are returning strings over here, because that's just the default behavior for these read lines. So yeah, keep that in mind. These are strings, and we are planning on treating them as numbers, so we will have to convert them. Let me I'll make a variable. I'll call it like total, and this is supposed to represent the sum of all of these numbers. Okay, here let me pull up these numbers over here real quick. Okay, cool. So we're looking at this number over here. Okay. This total variable is supposed to add them all up. So let's see what happens if I add them up. Line 1 plus line 2. And as a good programming practice, probably sanity check it. I'm going to go ahead and print the total here. So sum is, and then I'll do as like a f string. Okay, print that. Let me load the function in. There we go. And then let me test it. It's not done yet. I'm only sanity checking the sum. Okay, so let me press play here. Okay, you see how it says the sum is 12.23, and then here and here. This is not really the sum of all of them. It's actually doing a string addition or string concatenation. So yeah, what you're seeing here is it's adding 12.23 and a new line, and then 322.3 and a new line, but it's treating them as strings. So you got to convert them. One way you can do that is by using a casting or conversion, where you convert all of these. Okay. Okay, and let me verify the sum real quick. So press play here, and press play over here. Cool, sum is 363. This looks about right. The sum of all these numbers. And then now the function just needs to compare it. If the total exceeds 100, if total exceeds 100, then it's true. Else return false. Okay, there we go. So let me test this. Play and play here. This prints true, perfect. And then let's bring in the small numbers. The small numbers are right over here. Where are the small numbers? Here it is. These are the small numbers. The sum does not exceed 100. So it does print false right here. Cool, cool. So yeah, this is testing locally. Okay. By the way, I would consider this solution like a naive one, but it is sufficient for this class. I consider it naive because it's not that general. It would probably be better to do a loop, or represent this as a loop instead, because it'll be more general. Like if you were to go through all of the numbers for some reason, then you could generalize it a little better. Additionally, this right here, this tree of 2 branches, you can actually compress this into one. You can just return the condition here. So the return total is greater than 100. This is a shortcut. This is logically the same as these 2 branches. So I hope this makes sense, because the thing I highlighted is it returns a Boolean. So this is either gonna be true or false. Okay, let me get this back here. Okay, press play, and then press play over here. Cool, cool. Looks good. All right, yeah, there should be some fun stuff. Okay, any questions about this so far? Okay. Sounds good. Okay, let me see what else there is. Let me scroll through this Canvas quiz real quick. Okay, question 2 is this one. Okay, question 3. Boom. Question 4. Boom. Question 5. Okay. Cool, cool. All right, moving on to question 3. Okay, here we go. Okay. Looks like this one is testing our HTML stuff. It's been a while since we've done HTML, probably like a couple months. But this one is asking if you can write a function that generates a hyperlink. A hyperlink is like a clickable text. That's kind of like what it is. Like over here in the HTML lesson, there is a hyperlink. Oh, these are hyperlinks, by the way. You see these clickable buttons? These are hyperlinks. And then towards the bottom over here, you'll also see some. This is also a hyperlink, which leads you to some website. I'm going to click on it to see where it leads me. So click, and cool, it brought me to the syllabus. Yeah, so that's a hyperlink. Let's see. So yeah, write a function called link target. Takes 2 arguments. Takes a text and URL. Basically, the text is the thing to display, and then the URL is it's an address that represents some website. Okay. Let's see. We are expected to just return a string here, by the way. So there shouldn't be any display functions here. Uh, it's going to be up to the caller to display it for us. So this function should return just a plain string that contains the HTML representation. And then it is up to the caller to display it. So here's what I mean. Like, let's say, I'm pretty much going to copy this down right here. But let's lead up to it. So I'm pretty much saying here that the caller is this testing cell here. If the caller were to invoke the link target function, and it does take 2 string arguments. The first one represents the plain text that you can click on. So if I said like Google, and then the second argument represents the URL. So the caller is invoking this function, which should return a string. And if you store that string as this variable, then you should be able to display it. You know what I mean? That this is a plain string, and it's the caller's job to display it for us. So if they were to, well, first of all, you got to convert this string to an HTML object. And one way you can do that is by saying HTML link. We're converting a string to an HTML object. And then we can put that HTML object in the display function, which should display something clickable. Okay, this HTML object class does require a import. So let me go ahead and import it over here. All right, people cool with this so far? So hopefully you see what I mean by working backwards. Let's go ahead and define this function. So it's called link target. Takes 2 arguments. The purpose is to generate a string that represents a HTML hyperlink. Text. This is a string text to show. And then URL, this is the address to where it leads to where it leads to. Okay, and we are expected to return a string. Okay, very important that it returns a string. A very common pitfall is people would do the display function in here, but in this current design, it's the caller's job to display it. Hope you know what I mean by the caller. Okay, let's get started. I'm gonna go ahead and return a dummy return value for now. Just gonna return an empty string. I'm gonna return an empty string. I'm just gonna test it real quick. So test it here. Okay, cool. It's displaying nothing. Makes sense. If I said return hello and play here, it does display hello. Okay, cool. We're on the right track. Let's go ahead and get this done. Okay, cool. So yeah, you can pretty much refer to your HTML stuff over here in lesson 9. We're pretty much doing this over here. So just go in lesson 9 and check out the hyperlinks, or your lab. It goes over this stuff. So the hyperlink uses an A tag and then a attribute href. So let's go ahead and get that. I'll go ahead and make a string variable called my HTML. And then I'll make a multi-line f string, because we are planning on interpolating the variables into it. Okay. If you're not sure how to find stuff in your notebooks, then you can Google stuff up too, by the way. This is an open internet quiz. So you could look up things like HTML HTML hyperlinks and kind of check out how it works. So looks like this is a primary resource. I mean a secondary resource, but it's got some good reputation. So let me check it out. Now, once again, if you're not sure how to find things in your notebooks, you can Google stuff. So yeah, the A tag defines hyperlink, and then there is an attribute called the href, which indicates the URL. So yeah, we pretty much have to make an f string like this over here. Okay, cool. So let's see. So my HTML is equal to, there is an A tag. Don't forget the closing one as well. Okay, there we go. There it is. And then there is an href. And let me check the format real quick. Href is equal to some string. Okay, cool. So href is, wait, it's equal to some string. This string represents the destination to go to. So we need to interpolate this URL variable into here. And then finally, we need to get the text of it. The text is in the between these two tags, like over here. See the link text. So let's go ahead and link text over here. There we go. We just generated it, and let me go ahead and return it. My HTML. Cool. Let's test it. So play. And then play over here. Cool. Here we go. It properly generated one. And if you want to kind of deconstruct this, you know, sometimes your function might not work and you might wonder why. You could use some print statements. So if you wanted to sanity check some things, like print the HTML link. Once again, HTML link is a plain string. So this is the plain string, and it's being set into the display function here. So by putting HTML link here, it's gonna render a little nicer. Okay, people cool with this? Okay, here let me keep testing. Let's see. Let me just copy the second test case over here. So boom. Boom. This one should be going to canvas. So press play. Cool. It looks like it worked. And if you click this, it should lead to your canvas. So boom. Oh, potential security risk. Interesting. I forgot something here. Did I forget something? Potential security risk. Cabrillo.instructor.com. What the hell? What is potential security risk? Cabrillo. Did I get the URL wrong? Let me check. Let me go on Cabrillo. It might be, I might have messed up my certificates from modding my network earlier. Let me check. Canvas. Cabrillo.instructor.com. Yeah, this should be good. Oh, I guess it doesn't need the www for some reason. So let me take out the www. Let me try this again. Okay, cool. There we go. It leads to it. Yeah, I wasn't aware of that. Okay. People cool with this so far? Okay, great. Let's see. I'm just gonna let folks try the rest of this themselves, because I don't want to ruin any creativity. Probably a good idea to try it out yourself and get used to the problem-solving process, like looking things up and testing things yourself. So I'll let folks try this out. Question 4 is pretty much asking if you can write a function that accesses elements in the dictionary. That's pretty much. And then for the sake of this question, you can assume. If you're not sure what to assume, you can type it as a comment too. And I do read everything, so you can say, oh, I'm assuming something. Like maybe you can say, I'm assuming that the dictionary will always contain these 3 keys. So yeah, you could do that, and I'll grade it with that in mind. Okay, yeah, try this out yourself. Number 4, and then finally number 5. Number 5 is asking if we could implement a class. It looks like we already did this, the counter, but on the exam you're likely to get some sort of variation. Implement some other class. Okay, so yeah, we already did this. You can look at the most recent lab for this, the number 20. Okay, let me check if it's here. Lab 20. Yeah, we did this last week. Represents a tally counter. It's like remember I pulled up that picture of the digital thing. You press the plus button, press the minus button, and then there is we ended up implementing a reset button as well. So yeah, just stuff from last week. And then the last question on the exam is just an upload question. So when you're done, well, first of all, I would recommend saving like 10 minutes towards the end of the exam. But when you do this, you want to go ahead and upload it. So be careful on uploading right now, because I don't have this on my computer yet. So make sure you download this first. So download. Cool. So I just downloaded it, and then now you can click on choose a file and then go ahead and upload it in your downloads. Let's see. I'm not gonna click on this, but yeah. You see what I mean. Okay. Cool. Any questions so far? Okay, cool. So let's kind of conclude. Some final thoughts. This practice final is incomplete. It doesn't contain a remote checker. So it's just because I didn't finish it yet, but hopefully it's going to give some good programming practices, like being able to unit test yourself. Let's see. Okay, what else? Yeah, so some tips for studying. First tip is I recommend going through all of your previous labs, fully understanding everything, filling in the blanks that you might have forgotten about. And then I would recommend going over all your previous programming projects as well. We had like 14 in total. So if you fully understand all of your labs and projects, you should be pretty chill for this. This practice final doesn't really cover every single topic that you're gonna see. It's really just to practice the format. So there's gonna be some more material. There's gonna be one more question. Okay. Let's see. If folks need more practice, if you want, you could look up some practice, like maybe Python function practice. Python functions practice. You could Google this. Let's see, is there a good one? I guess the first one is fine. This is a secondary resource, but it's got some good stuff. So there are some sample questions here. Let's see. Let me see. Yeah, you can do this one. This one, yeah, you can do that one too. That one. Ooh, factorial of a number. Interesting. This is a good one, actually. You should probably try these out. Check of a number. Count uppercase. That's a good one too. Boom. check whether or not a number is prime. That's good. That's a good one. This is like maybe asking if you can do a for loop, because to check if a number is a prime number, you kind of want to loop and check if it's divisible by any number. Let's see, number 10, print even numbers only. Oh, so this is a filtering algorithm. And then okay, it looks like it gets harder after 10. If you can do the first 10 of these, that might make you feel a little more confident. Anything past 10 will just be to challenge yourself. This would be a good idea to do over the winter break instead. So yeah, first 10 over here would be good. Okay. Cool. All right. Yeah, that's it for today, folks. It's gonna be a short day, and we are at the 1 hour mark. If folks want to kick it, I'll stay here for another hour. But yeah, other than that, thank you all for being here, and folks on the recording, see you all soon. Let's see. I just realized this is the last lecture, so see, I'm not that good at goodbyes. Usually in person, I'm better at goodbyes. But yeah, if you're gonna take some more computer science classes and stuff, I'm in the STEM center like every weekday, so you can pretty much catch me there, and I'll help you out with homework in your other classes or whatever. So it's all good. I'm usually on the server side, so if you go in the STEM center, just look for the servers, like the data center. I'm usually hanging out around there. Okay, thank you all, folks, and have a great Thursday.
Thank you so much.
Thank you.
Thank you.
Yep.
And I will find you because I got so many projects in mind that I need your help on. So I'll find
Yeah.
you over there.
Yeah, we should go through it. You have some cool projects going on.
Yeah, I got a lot of ideas, and so yeah, I'm sure you can help me with them.